Okay, can we start? Are you okay? I'm feeling okay today. So hopefully all of you are okay. We are a bit behind. But don't worry. Okay, can you see the slide?
Yes,
Okay.
doctor.
Okay. So this is. Let me close the window first. Okay. Okay. So for this lecture, we will look into the introduction to IR model. The basic concept that we will look into will include Boolean model, term weighting, the vector model, and also the probabilistic model. Yeah. So when we talking about modeling in IR, this is a very complex process in which what we're trying to do is we want to use ranking function that can be used to assign score to document. So for example, all of us use Google query or Google in order to find document. So when we type in the query, the Google system will provide you a list of documents. So this is like a ranking. A ranking depends on how relevant is the document with respect to the query. Okay? So the process consists of two main tasks. Okay. The first one is how do we represent the document and the query? As we know about the document, we know about the query, but how do we represent them in a system, in a binary system? Okay? And at the same time also, um, after we represent the document and the query in binary, how do we actually perform the ranking function? So the ranking function is used to rank the document based on the query that we have. And of course, for each document that we have, or for each information that we have, we adopt the index term. So the index terms are those terms that are selected to represent the document. So for example, we use person name, things name, place name, idea name, or concept name in order to represent the document. Okay? So for example, if you are looking for looking for a document related to your project or related to your assignment, you must have some idea of what key index that you need to key in. So that is what we call the index term. Okay? So the retrieval based on index term can be implemented efficiently since index terms are simple to refer to in a query. Because normally we use keyword in Google. So when we type in the keyword, that is the index term that we apply in this case. So when you're typing a query, simplicity is important because we do not want to have so many terms in one query. So maybe you can have 2 or 3 words. You do not want to type the whole sentence in a query. Okay? So for example, like this, so this is you. Okay? So you need some kind of information. So what you do, you type in the query. Okay? And this is the document that stored in a server. And they are indexed by using some kind of indexing. They use keyword, they use what we call it, indexing. Okay? So whatever you query, whatever you type in here, they will look at the matching of the area here. So whatever match, they will retrieve those documents and they perform the ranking. Okay? So this is the problem that we will look into in this course. Given a query, how do we perform the matching? How do we perform the ranking? And before we can go further here, before we can further ranking here, how actually we represent the document here, and how actually we represent the query here. Okay? So the whole idea is, if I go back to this, we want to learn how do we represent the document and the query, and at the same time also we want to learn how to use a ranking function that allows us to quantify the similarity among document and query. So this is the two ideas that we want to study in this course. Okay? So for that one, we build an IR model. So IR model consists of quadruple, 4 element, 4 item. So the first one is the document that you have. The second one is the query that you have. And we also have a framework for modeling document and query. So this is the framework that we use to represent the document and the query. And the fourth one will be how do we perform the ranking between each of the document with respect to the query. So the QI is the query, the D will refer to the document. So this is a vector of document, this is a vector of query. So in IR model, we have four items, the document, the query, the framework, and also the ranking function. So this is the taxonomy of IR model. What we will do is we will not look into link and multimedia. We focus on text only. So the text only, we focus on classic IR model, Boolean, vector, probabilistic, and we will look into this. But in general, we will look into the Boolean model, the vector model, and probabilistic model, these three. So we will not look into this. Okay. In an ad hoc retrieval system, what do we have is that we have query 1, query 2, query 3, query 4 sent by different user. Okay. But for this one, we have a set of collection. So whatever match to the user, it will send back to the user. We also have filtering. In filtering, it depends on the user profile. So different user will get different result depending on the keyword that they key in. Okay? So they are filtered based on your profile, based on your background. Everyone okay? Can you type number 2? If you're listening. Oh, 15 people only yang respond. Yang lain mungkin not listening. Okay. We continue. Okay, so the basic concept here is that we use keyword or index term. So an index term is a word or group of consecutive words that we use to represent the document. So we call it set of index term. Okay. So for example, let's suppose we have T be the number of index. So T is the number of different unique words that we have in that document. So for that reason, we will have 1 up to T number of keyword that we have. So this is your vocabulary for your document. So we have keyword 1, 2, 3 up to T. So we have T number of index term. So this one means T unique term that we found in the document. Okay. So in order for us to say that keyword exists or not exists in a particular document, for example, like this document only have keyword number 1. compared to this document has all the keyword that we have here. So we use this one, we use binary, we use true and false in order to say that that keyword exists in that document or not. So one row is called one vector. Okay? So for each document that we have, we associate a unique term conjunctive component, which is a combination of terms. Okay? So for example, like this. For D1, we are saying that there exists keyword 1, n, this is n, because for the n, for the expression to be true, all must be true. So we negate this one to become 1, so that true and true will become true. So that's why we have this not. Okay, so by having this not notation, we have the whole expression to become true. Okay? Compared to the last one, we just say keyword 1 exists and keyword 2 exists and so on. So this is how we express each document. This is what we call conjunctive component, a combination of component that we use and in order to combine them. Okay? So when we convert this one into matrix, so we will have something like this. This is keyword number 1, keyword number 3, and so on. This is document number 1, document number 2. So this one indicate the frequency of this term in document 1. Okay, for this one, this refer to the frequency of keyword 2 in document 2. Okay, so when we have something like this, D1, D2, and then keyword 1, keyword 2, keyword 3. So if we have 3, 2, 0, 1, 2, 1, so that means keyword 1 exists 3 times in document 1. Okay? So when it comes to this matrix, so what we want to do is we want to list all the vocabulary that we have, keyword 1, 2, 3, up to T. So for us to list all of them, we need to follow this logical view of a document. So from a document, we remove all the blank spaces, we remove all the stop word, we gather all the noun group, we perform the stemming, and lastly, we will have the control vocabulary, which means that from a single document, we will extract all the unique keyword that we have in that document. So we perform all this function. We will go over this one, but don't worry about this. I think in the next 2 lectures, we will cover this. Okay? So any question? Ada soalan? Okay, so by now you should have an idea how do we represent a document in a framework. So this is how we represent the document. So we list all the keywords that we have, and then we will look at how many times each keyword exists in the document. So this is what we call term document relation ataupun term document matrix. And now we go to the first model. The first model is called the Boolean model. As we know that Boolean referring to binary number, okay? 0 and 1. Okay? If we refer to this example refer to the frequency of the term. Okay? And the Boolean model apply this concept in which they only use binary number to show whether that keyword exists or not in the document. Okay, so we will go over this one, the first one, the Boolean model. Okay, this is a simple model based on set theory or Boolean algebra, in which the weightage is only between 0 and 1. Okay, so sama ada 0 ataupun 1. If 0 means they do not exist. If 1 means they exist in the document. Right? If you look at the query here, for this expression to become true, this one must be 1, and either this one will become 1 because we have O, kan? So either this 0 or 1 ataupun 0, 1 ataupun 1, 1, 1. Okay, so for the time being, let's say this is our query. Okay. So the query says that I want to have keyword 1 and keyword B or not keyword C. Okay. So if you look at the next one, this is what we call the query just now. We only have 3 vocabulary A, B, C. So like I mentioned just now, for this expression to become true, I must have 1, 0, 1 ataupun 1, 1, 0 ataupun 1, 1, 1. Okay. So we have 3 options here. So for that reason, either I can have this or this or this. So this is what we call disjunct normal form because we're using or. We're using or here. So sama ada, I go back here, 111 ataupun 110 or 101. Okay, so is there anyone here still confused? How do we get the 111, 101, and so on? You learn your programming already, kan? Okay. So if this is for the Q to be true, this one must be 1, and this is N. Tapi we have this, or so sama ada you have one of these true or not, it's okay. So either 0, 1 ataupun so we have 1. One N, 1 or 0, okay, or 1 N, 1 or 1. So all those is here. Okay. So when we look at the Boolean model, so all of this area will cover that area. Okay. So this is the expression of Q. This is the area cover. Okay. Okay. Let me give you example here. Consider we have 4 keyword here. So we have 4 keyword here. And let's suppose we have a document that contain A, B, C. So we have A, B, C, and we do not have D. Okay? So when we talk about the query just now, we have A, B, C here. So since we have the fourth element here, and the query is only up to C, so that means we only look after 3. So this we don't care. Whether 0 or 1, we accept also. Okay. So similar to this also, we have 3. So we don't care about the fourth keyword, either they exist or not exist, because our query does not cover D. Okay. So similar to this and this, so we do not cover this and this. So this is the disjunct of normal form for this query if we have 4 keyword. Okay. Okay. Now it comes to how do we measure the similarity between the document and the query. So in this case, we are saying that the similarity function is 1 if there exists a conjunctive function Q such that the conjunctive function of Q is equal to the conjunctive function of the document, which is similar. If you have this query Q, in the document also, we can have the same expression. Okay? For example, like in the previous example, let me go back here. So here, the similarity between, let's suppose we have document 2 and we have 1, 0, 0, dot, 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 0. So we say that document 1 and 2 are similar because each keyword matching 1, 0, and so on. Okay? So for this one, we are saying that they are matching if all the expression in the query is the same as in the document and 0 otherwise. Okay? But the disadvantage of the Boolean model is that we cannot do partial matching. There is no ranking because we have true and false. There is no gray scale. And also this is too simple and we cannot, and the main idea here is that we need a framework that can be used to rank the document. So for the Boolean model, we cannot have this module to be used in order to perform the ranking. So for that reason, we move on to the next one. We call it term weighting. So term weighting, we use frequency. we use how frequent is that document exists in the document. Compared to the Boolean model, we only consider whether the keyword exists or not exists in the document. Okay, so for the term weighting, we are looking at the frequency. We are looking at the weightage here is greater than 0 and not only 1. So if the keyword does not appear in the document, then the weightage will be 0. So the weight that we have can be used to quantify the importance of index term k or describing the content of the document. So we will look into the term weighting here. Okay, for example, like this. For each keyword, we will have the weightage of that particular keyword with respect to the document. Okay, so we no longer use 0 and 1. We use some kind of weightage. So this weightage could be the frequency of that particular keyword exists in that document. Okay. So like I mentioned just now, this weightage, we can use the frequency, total frequency of occurrence for this particular keyword. Contohnya, we are looking at how many times this keyword F exists in the document. Okay, so this N refer to number of document that we have. Okay, so this is the total number of frequency of occurrence for term Ki. Okay, so for example, like this is a simple example that show the frequency of each of the term that we have in each document. So for example, the frequency for do in document 1 will be, document 1 is here. So how many times do 1 and 2? Okay. And the frequency of do in document 3 is here. And we have 1, 2, 3. Okay. And the total frequency of do in all of the document will be the total of this one. Okay. And the number of document that consists of do will be 3. So we have 1, 2, 3. Okay. So document 1 we do not have the do. Okay. Boleh faham? So we have to be able to differentiate the small f here refer to frequency of that keyword in the document. And the big F here is referring to the total number of occurrence of this keyword do in all the document. And N here refer to the total number of document that consists the word do. Okay. So boleh faham? Sometimes ada juga term that we have that always come together like software engineering, computer science, information technology. So this is what we call term correlation matrix, in which two terms always come together in any document. Okay? And there is a way on how we measure the term correlation. How close they are correlated to each other. Okay. So this is the formula. We will use the matrix term document matrix. So the term document matrix is basically this one. Okay. This is your term document matrix. Let me erase this. Okay. So this is your term document matrix. Okay. So we will use this term document matrix in order to compute the term correlation. Okay, so the matrix that we have just now is this one. Okay, and what we can do is we can compute the term correlation by taking the transpose of the matrix and then multiply them by the original matrix. Okay, so each element of the weightage that we have will express a correlation between term KU and KV. So this one will, the weightage here if higher, that means keyword U and keyword V are closely correlated to each other. Okay, let me show you the example. So this is your matrix. We take the transpose. So the transpose means the row going to column, column going to row. Okay, so we take the transpose. This is the transpose. And then we multiply. So that means we are going to multiply that one and this one. So that is this. This multiply with this plus this multiply with this. Okay? Then we get this number. Okay? And we get this number also. So how do we get this? We take this. Let's change color. So we take this, multiply with this, then you get this one. Okay, so that means weightage keyword 1, document 1 times weightage keyword 2 and document 1 here. Then we add up them together. And then the last one is we take this one again and multiply with that, we get this one. Okay? So the number that we get here, each one of these, the higher they are, the more correlated they are. Okay? So for example, like this is an example. This is 2 documents with 4 keyword. So when we multiply them, so we get this. Okay, so this number saying that keyword 3 and keyword 4 is highly correlated to each other. So this is how we use the term document matrix in order to find the term correlation. Okay. Everyone okay? Can you type number 7 if you're still there? The last part of the lecture called TF-IDF weightage. This is the most important parts. After this, I will post the assignment for you to do, which is due 2 weeks from now lah. Okay, and so far we have studied the Boolean model. We also have the term weighting model. Okay, so now we go into TF-IDF weightage, in which this is an improvement of the previous one. So they use similar concept also here. Okay, so the one that we have gone through so far is this one, because we use the frequency of the term. Okay, but what we want to introduce here is that we want to introduce this inverse document frequency again. So what we want to do is we get the term frequency and we multiply with IDF, which is the inverse document frequency, and we get this. Okay. Okay. If we look at the term correlation matrix just now, right? Okay, when we look at the term correlation, we found that we can find two terms that are highly correlated to each other. So we use the term frequency in order to determine the frequency of each of the keyword that we have in the document. Okay. So for example, like this, this is a variant of the term frequency that we have. This is your basic one. So what they add is this log base 2. So instead of just computing your frequency here based on the frequency, they apply the log base 2. Okay, so your new weightage for the TF-IDF will be 1 plus log base 2, and this is the frequency that we have. Okay, and later on we will also discuss why do we need the IDF here, which is this one. Why do we need that one? Okay, so let me look at how do we compute the term frequency here. So for example, in this example, in document 1, this is document 1. So the two here exist how many times? 1, 2, 3, 4. Okay, so we have 4 here. So this is the formula that we applying. So we have 4. So when we compute this, we will get 3. And that's how we put our weightage here is 3. Okay, boleh? Okay, let's suppose we look at document number 3. How many times do exist? 1, 2, and 3. So we plug in the value 3 here and we compute, we get 2.58. So we have 2.58. Okay. So now with a new formula, the term frequency is used to compute the new weightage, which is using 1 plus log base 2. Okay, so this is a variant of term frequency only. Okay, so from now on, we will use this term frequency weightage. Okay, and remember that when I say we have IDF, okay, the reason why we introduce IDF is that if you look at this one, okay, so the word B exists in all of this document 1 up to 4. So we cannot use the vocabulary B to differentiate the document because all of them have this. So what we want to do is we want to cancel out this. We want to make this one 0, all 0. So that's why we introduced the IDF. Okay. So the formula for IDF is this, in which let Ki be the term that exists in only Ni document. So this one refers to how many documents that contain keyword I. Okay. So this is the total number of documents that we have. Okay. So if we have, for example, like this, if we go back here, this is the formula for IDF. Okay, let me write down here. Okay. So the number of document that we have is 4, and the number of document that has this keyword is also 4. So if you compute log base 2 1, you will get 0. So that means all this will be turned to 0. Okay. So this expression will become 0 if n equal to ni. Okay, let me show you here. Okay. So the IDF for B will be 0. Okay, because the expression will be, because we have 4 documents and we have 1 as B, and we have 4 also, number of document that consists B. So this is equal to 0. Okay. How do we get this one? So this one is log 2. We have 4 documents. And then for the 2, how many exist? 1, 2, only 2. Okay. So this one should give you the expression 1. Okay. So this is the IDF. So since we are going to use TF-IDF, so what we want to do is, this is your term frequency, this is your IDF. So we will multiply them. So this is our TF, this is our IDF. So we will multiply this with this, and we get the new updated TF-IDF. So this is the new weightage for all the document, no, for all the term in all the document that we have here. So notice that we have cancel out the weightage here because we have 0 here, and if we multiply with this, all 0. Okay. This one we multiply with the last one, we get 4. Okay. So this is your TF, this is your IDF, and this is your TF-IDF. Okay. And as you can see that this only has 3 words. This has how many words? 6. This one has 5. This one has 4. Okay. So each one of them will have different number of words. So we can compute the length of the document by computing the size. So that means given the weightage that we have here, then we will get the square of each of the weightage that we have, and we sum up all of them. So for instance, for this one, the length of the document D1, the length will be, this is the length of the vector D1 will be, we simply use this formula, which is take the summation of all the square of the weightage and take the square root. So we will have square plus 0.83 square plus 4. So this is the length of the document. Okay. So the length of a document is here. So this one, you should be getting this 5.068 from here. So this is 5.068. Okay. 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 Since we have this TF-IDF, now we can perform the ranking. Okay. So we call it the vector model. So for the vector model, we use some kind of similarity function or ranking function in order to measure the distance. Okay. So given this vector for your document and given this vector for your query, okay. So remember that this one is your TF-IDF for keyword number 1. This is your TF-IDF for keyword number 2, and so on. Okay. So the similarity between the document and the query can be measured using the cosine function. So the smaller they are, the more similar these two documents between document J and the query. Okay. So what we need to do is we just take the vector multiplication, and also we look at the length of the document multiplied by the length of the query. Okay. And we get the number here. Okay, let me show you one example. Referring back to what we have studied before. So this is what? TF kan? And this is what? IDF. Okay. So this is the term frequency for keyword 1 in the query. This is the IDF for keyword I in the query. And this is in the document. They are similar. Okay, let's suppose we have a query. A query consists this to do. Okay? And the vector for the query will be, okay, this is the weightage for to, and this is the weightage for do. This is for the to. Okay? And there is a comma here, and we have one more here. So this is for the do. And we have 0 here. Since document 1, we have three items here. So we have 3 point at 3, 0, and 4. So we have to match with the query here. Okay. So for the 2, it exists only one time, and the IDF for 2 is 1. Okay, so that's how we get this one. And then when we solve this one, we get number 1 here. Number 1 here. And for the do, we exist one time, and we have the IDF here. So we put here. So we get this one. Okay? And of course, the last one is 0 because we do not have is dalam query. Okay? So we have the query vector, and also we have the document vector. So now we just have to use this number in order to perform the ranking. Okay? So what do we do now? We use the formula that we have here. Okay? So how do we perform the formula? Okay. First, we multiply 1 with 3, and then 0.4 with this, and then 0 with that. So that is the first part of the equation, and then we divide by, remember this one, this is the length of the document that we have. So this is the length of query. This is the length of the document. Okay, so this is the length of the document. This is the length of query. Okay. So once we solve this, we have this ranking. Okay. And you should be getting this one, because that is between the query and also document 1. Okay. So the vector model is the best model that we have now, because we can ignore some of the terms that exist in all of the document. We can cancel out the weightage, and also we can perform the ranking easily. And also we can perform the document length normalization by computing the weightage of the document itself. So um, I hope everyone can follow. It is difficult to follow through online, but you need to go over the lecture a few times. Okay. Any specific question? You so I will also post this video. Um, so hopefully you have the video that I posted before and also this one. So try to look into that. You need to spend time on your own and study on your own pace. Yeah. Need to be more proactive in this new norm. I will post the assignment for this one, but I hope everyone can understand lecture 3 because this one will be your foundation for the next few more lectures. Okay. So any other question? Um, there is exercise here, but this one is previous exercise. I will try to post the previous exercise punya solution so that you can look into that and start doing your exercise. The actual exercise that I will post in the Smart um, version 3. Okay, so the only thing that I changed is this one. Okay, so for example, like this. So you need to form the TF-IDF and then perform the ranking. I will try to look for the solution for this, and then you look at the actual exercise lah.